For this video, we are going to learn how to solve a rational inequality algebraically. So remember that a rational equation is an equation with a rational function, meaning there's a fraction, a polynomial divided by another polynomial. To solve a rational equation, we find the LCD and we cancel out our denominators. To solve a rational inequality or to solve any inequality, we always work with the equation. So I'm going to pretend this is x minus 4 over x plus 5 equals 4. And our first step for solving a rational inequality is to determine where a function is undefined and plot those numbers on a number line with open circles. So if I look at my denominator, x plus 5, this would be undefined at x equals negative 5, meaning x cannot be negative 5. This is my undefined value, meaning it's excluded from the domain, meaning I'm going to need an open circle on the number line. So here's my number line. I don't know what other numbers I'm going to have on here right now, but I have negative 5 with an open circle. Now I need to solve my equation. So for this particular equation, it is set up as a proportion. So if we wanted to, we could put this over 1 and cross multiply. And we get x minus 4 equals 4 times x plus 5. So I have x minus 4 equals 4x plus 20. Subtract x on both sides, subtract 20 on both sides. So we get negative 24 equals 3x. Divide by 3, so x equals negative 8. So if this was an equation, this would be my solution. And in this particular question, I had less than or equal to. So that means my solution gets a closed circle on the number line. So I'm going to put negative 8 on my number line, and I'm going to fill it in with a closed circle. Now I need to choose a test point from each of my intervals. When we did polynomial inequalities, we looked at the graph. But for rational functions, it's sometimes difficult to analyze the graph because there are so many additional features like holes or asymptotes. So for rational functions, we are going to choose a test point. And I'm going to choose a test point in each interval. So for example, in this interval here, I'm going to test x equals negative 10. In this interval here, I'm going to test x equals negative 6. And in this interval here, I'm going to test x equals 0. If you chose different test points, it would not matter as long as they are 1 in each interval. So here are my test points. X equals negative 10. And you are going to test it by substituting in to our original inequality. X minus 4 over x plus 5 is less than or equal to 4. So I have negative 10 minus 4 over negative 10 plus 5. I want to know, is that less than or equal to 4? This gives me negative 14 over negative 5, which gives me a positive 14 over 5. Is that less than or equal to 4? Well, I could rewrite this 4 as a denominator of 5. It would be 20 over 5. So this is a true statement. 14 over 5 is less than or equal to 4. So because this is a true statement, I am going to shade where that test point was. Now I am going to test my next point, and I chose x equals negative 6. So I have negative 6 minus 4 over negative 6 plus 5. I want to know, is that less than or equal to 4? So I have negative 10 over negative 1, which gives me a positive 10. Is that less than or equal to 4? It is not, so it is false. So I am not shading in that area. My last point on the number line is x equals 0. So I have 0 minus 4 over 0 plus 5. I want to know, is that less than or equal to 4? That gives me negative 4 over positive 5. Is that less than or equal to 4? Yes, it is. That's a true statement. So I'm going to shade that area of the number line. The number line is your solution, and then you are going to express your answer in interval notation. So my number line extends to negative infinity. Remember that infinities always get a parentheses, to negative 8 with a bracket since there's a closed circle. Then it picks back up at negative 5 with an open circle, so I have a parentheses, to infinity, which also gets a parentheses. So that is the solution to my inequality. Example 2. I'm going to start the same way. I am going to start by looking at my undefined values. Undefined values come from my denominator. So in this case, it's just x cannot equal 0. So on my number line, remember undefined values always get an open circle. So I have an open circle. This particular equation, well, first it's an inequality, so let me rewrite it as an equation, is not set up as a proportion. So I am going to use my LCD. My LCD is 8x. I want each of my denominators to be 8x because once my denominators are all the same, I can cancel them. So I look at each piece and analyze what's missing. My first denominator is an x. I want it to be an 8x. So the top and the bottom get multiplied by 8. My second denominator is an 8. I want it to be an 8x. So the top and the bottom get multiplied by x. My last denominator is a 1. I want it to be an 8x. So the top and the bottom get multiplied by 8x. So I'm left with 8 times x minus 2 over 8x, x squared over 8x, and 8x over 8x. Once your denominators are the same, you can cancel them out and focus on your numerators. So my new equation is 8 times x minus 2 plus x squared equals 8x. So I have 8x minus 16 plus x squared equals 8x. Anytime I have a squared or a quadratic, I want it equal to 0 and in standard form so I can factor this. So first I'm going to rewrite this into standard form. And then I am going to subtract to get my polynomial equal to 0. This is dots, so it becomes x minus 4, x plus 4 as my two factors. When I tee off, I get x equals negative 4 and x equals positive 4. These are my solutions or my critical values because those are my solutions if this was an equation. But my overall question was an inequality. So I go back to my original question. This says less than, so it's an open circle. So negative 4 and positive 4 get labeled on my number line with open circles. Now I need to choose test points. So I am going to choose x equals negative 5, x equals negative 2, x equals 2, and x equals positive 5. Remember, you can choose different values as long as you have one in each interval. When I go to test, I have to test in my original inequality. So at this point, you should pause the video, try each of your test points, and then when you're ready, hit play and you can check your work. So hopefully by now, you've been able to test each of your 4 points. If you chose the same points as me, you could check your work. So for x equals 5, this was true. So I'm going to shade in that area of the number line. For x equals -2, it was false, so I am not going to shade that area of the number line. For x equals 2, it was true, so I'm going to shade that area of the number line. And for x equals 5, it was false, so I am not going to shade that area of the number line. Then your last step is to take your number line and write your answer in interval notation. So -infinity, which always gets parentheses, to -4 with the parentheses because there's an open circle. It picks back up again at 0, which also gets an open circle because it is also gets a parentheses because it's an open circle, and goes to 4, which also gets a parentheses because it's an open circle. So that's how you solve rational inequalities.